Now next topic, that is electrical energy power. Now see, suppose we consider any conductor, the resistance of which that is R, and current I is flowing through this resistance R. Now here these two endpoints of the resistor R are denoted as A and B, and the current is flowing through the resistor from A to B. Now we know this thing, current always flow from high potential to low potential. It implies that when current is flowing from A to B, then we can say this thing, the terminal A of the resistor R that will be at higher potential and terminal B that will be at lower potential. Suppose potential at A that is VA and potential at B that is VB, then we can write here VA is greater than VB. So potential difference between A and B that we can write V equal to VA minus VB. Clear up to this one? બોલો it. બોલ it શું હતું?
સર રેકોર્ડિંગ બંધ હતું હવે ચાલુ છે.
Now suppose delta Q amount of charge is flowing in time delta T, which constitute this current I, then we can write delta Q that is I into delta T. Now, when this delta Q amount of charge is at terminal A, where the potential is VA, then we can say the potential energy of charge delta Q at terminal A, that is U at A equal to delta Q into VA. And when this charge delta Q reaches at B, where the potential is VB, its potential energy at point B will be UB equal to delta Q into VB. Therefore, when this charge delta Q is transferred from terminal A to terminal B, change in its potential energy delta U that is equal to U at B minus U at A, that is equal to delta Q into VB minus VA. But we can write VB minus VA, that is minus V. So delta U equal to minus delta Q into V. Clear up to this one? Now, as per law of conservation of energy, we can write delta K plus delta U that is equal to 0. So delta K that is minus delta U. Substitute the value of delta U, that is minus delta Q into V. So this is equal to minus delta Q into V. Therefore, change in kinetic energy, that is delta Q into V. Now, as per work energy theorem, the change in kinetic energy that is equal to work done. So we can write delta W that is equal to, now here substitute the value of delta Q I into delta T. So we can write delta W that is VI delta T. Now if we take this delta T on left hand side, then delta W upon delta T. So this delta W upon delta T, that is called electrical power consumed. in this process when delta Q amount of charge is transferred from terminal A to terminal B in time interval delta T. So, electrical power consumed P, that is equal to V into I. And this electrical power consumed, that is converted into heat. So we can say the electrical power consumed P, that is V into I, itself is the heat produced per unit time. And we can write this equation like this also. If we substitute V equal to IR, then power P, that will be I square R. If we substitute I, that is V by R, then power P, that is V square by R. So we can say this is the electrical power consumed, or we can say the heat produced per unit time in this process. Clear to all of you?